Our project Finalists is a device which provides another option to the obstructive cochlear implant. The name Finalists is a mix of phonics and invisible, and as this is an invisible version of the cochlear implant. The small device is implanted into the skull, and using thin electrical wires, it is gently connected to the brain tissue. From the same device, a thicker wire is placed under the skin of the patient, connecting directly to the cochlea. The small device transmits the sound waves into electrical impulses. This will create a direct pathway for the sound waves electrical signals to go from the ear to the brain. The aim of our project is to allow people to hear without the worry of the cochlear implant. We produced this idea as one of my friend's cousins is unfortunately hearing impaired, being self-conscious about his cochlear implant. He feels as though he's seen as the disabled kid at school and doesn't want to be taken advantage of. This replacement of the cochlear implant will be hidden, creating a solution to this problem. The concept of the device is demonstrated using an Arduino and a 3D printed skull. The breadboard is indicating the brain in the model, and there is a speaker in the model to assist with demonstrating the functions of the device. The Arduino is connected to both the breadboard and the speakers. Lights are used to show the working of the model, and when speaking to the ear, the lights will flicker as the sound waves travel through the wires. This was the original prototype, and we used the following program on the Arduino. We previously only had a sensor able to sense the presence of noise demonstrated through a constant light, but we have improved this by making a new prototype with 3 lights, each with a different use. The red LED will be lit up if the decibel range is too low to pick up any noise, for example, if nobody is speaking or if it's too soft. The green LED will be lit up when the decibel range is within the normal speaking range. The yellow LED will light up when the decibel is too high. This represents adjusting the volume outputted into the system to be readjusted in real time accordingly. When speaking, the LEDs flash between different LEDs. This is showing the system making the adjustments in real time depending on the input. This is our prototype. We used a 3D printed skull and Arduinos. So this is the original. The breadboard indicates the brain, and the little speakers like the ear, and the wires are going into the brain as mentioned before. And when I speak into it, the lights glow at a constant rate. This is the new prototype. So we have the same electrical wires going into the brain, which is indicated through the breadboard, and the same speed.
Can you just hold it up a little bit more, please?
Yeah. And then there's the red, green, and orange light, which indicate if like the sound is too soft, too loud, or adjusting. That's the program that we used on the Arduinos. The sources we used is various medical experts to assist with the project, and we also used many websites for research on the anatomy of the ear.
Hi, my name is Bowden, and this is Alchemy. The problem that we want to help solve is increasing our kids' exposure to other cultures. We've noticed that many students at our school, A, are monolingual, and B, have only ever experienced Western culture. Our website, Connected, was designed to introduce students to languages and cultures from different corners of the globe. It allows students and classes to video call each other and virtually collaborate over work.
We believe that if our kids experience different cultures, they will be more open as global citizens in the future, will develop better social skills in life, and will have a greater acceptance for everyone.
They'll be able to form invaluable friendships with someone who may not speak their language yet have similar interests to them. They will learn that language and culture are something that can bring us together.
creating the website, we had to keep in mind that the website would be used all over the world, so we added a translation feature. It's currently available in English, Italian, and Japanese. Additionally, we had to accommodate the different time zones as seen here. The idea was for Connected to notify the user if the school they wished to video call or chat with was outside of normal business hours. With more money to give us access to better technologies, we would have significantly improved both of these features. While creating the website, we strove for our three key values of communication, being able to reliably communicate in multiple languages with other students, compassion, building a sense of acceptance for multiculturalism in Connected's users, and collaboration, providing the services to virtually collaborate with other students to complete online work.
Firstly, the classroom teacher will register via this page. Before the first heats, our website had a standard level of security with details such as full name, email address, school, and phone number needed to register. However, teacher accounts have been added with different interface and different permissions to students. When the website is published, all principals receive a code to pass on to teachers using the website. This code is needed to register as a teacher, which the website will remember, although will ask for confirmation on occasion. Teachers are able to edit their profile for their school and schedule full class video or audio calls.
Once registered, teachers can allow their students to also create accounts under them. Students will enter a name or email and a password to log in.
There is an account page dedicated to messaging students and teachers from partner schools that is easy and efficient to access. Pages displaying the profiles for partner schools are displayed in the menu, as well as the search bar, to view the profile for any school, including a brief description, pictures, and a Google Maps links, all of which can be seen in these three examples.
Once a student or their class accesses the video call menu, they can choose whether they want to collaborate with their partner school over work, or just talk to them via video calling.
If a student wants to video call their international classmates to virtually collaborate over work, they will click on the first button and come to this page.
Scrolling down to here, as well as video calling their partner, they will have these two options: to upload the same worksheet with this button and submit it when they are done, or to connect their laptop to a digital classroom camera above them, if it's available. In the latter scenario, the international classmate would be able to see them completing a worksheet as well as the video call in real time. This step is yet to be completed due to the limitations of the technology available to us.
On the other hand, a live chat is available via the same web page.
What sets Connected apart from other applications like Skype, Microsoft Teams, or Blackboard Collaborate is that we have designed this for students from all over the world. It is not meant to be a chore or a means to submit an assignment. It's a tool for us to connect with students in different countries with the services to do so, like translation, for a short chat or to help each other with work. It is a classroom resource that is better suited to communicating with students in other countries than applications like Zoom.
The use of our website is made nearly indispensable by the current COVID situation. With learning being more technology-based and increasingly having to complete our homework online, our website merges these changes with an opportunity to explore the world while sitting in front of your computer. But COVID-19 aside, Connected can be used for something as mundane as collaborating over weekly homework.
Ultimately, we created this website to combat racism in our community, to change our peers' negative attitudes towards people who may not look or talk exactly like them, and to show them how many learning opportunities out there if they are willing to approach them with an open mind.
Thank you for your time and consideration.
Hi, my name is Keshav, and I was in charge of creating the presentation that got us to where we are today.
Hi, my name is Edward. I'm responsible for the live camera feed.
Hi, my name is Hubert. I'm responsible for the research of bees.
And together, we're the Healthy Hive team.
Bees are important for both human and ecosystem. Bees pollinate our plant and allow plant to reproduce through pollination. Without bees, they would deck fewer seeds and would have lower reproductive success, affecting agriculture and having global food shortage. Now I'm gonna hand over to JJ.
So we're currently using a Raspberry Pi and a Shield sense hat to gather the data. The sense hat measures the temperature, the barometric pressure, and the humidity of the environment around it. We eventually ended up using Initial State, which is a website that basically takes the data from the Raspberry Pi and organizes it in a way that's easy to understand and use. As well as line charts, you can also have gauge charts and various other forms. Mr. Simpson, who's our head of beekeeping here at Halebury, really liked the idea. And when we also want state, we realized that we have to take it up a notch. So we eventually created healthyhive.co. This is a website that we created ourselves with little to no teaching. So here you can see the temperature graph, the pressure graph, and the humidity graph, each of them with their timestamps and the data. Down here is a gauge chart. Now here you can see whether the conditions are optimal, green area, or whether they're not so great for bees, the yellow and the red. We also had a camera here, and I'll hand it over to Ed to explain how that works.
So we have a USB camera that uses an IP address to access a live camera feed. To do this, we installed a package called Motion, which allows us to access the camera. As you can see here, the bees are shown on the camera.
Here you can see that there's a lot of activity around this hive, which is incredibly useful to know for beekeepers. However, there's not much here and here. Now, if you're a commercial beekeeper, you have to know this. You have to know which hives are being productive at different times, so you can prioritize them and know which ones to tend to. So that was the reasoning behind why we needed this live data, live feed. Now, here's the code that we had for our website. Up here is all the CSS and the HTML format. So this is how the header works, and then here's our logos and the banner at the top. Here's a little bit of PHP to connect to the SQL database, which we created to store all of our data. Here's the Google Charts part. So we basically use the Google Charts API to arrange our data in a way that actually in a graph. We spent a lot of time trying to get this part to work because we had to format the data in a way that was friendly to Google Charts API. We eventually came up with this PHP code. Here you have the callbacks, you have the options here, and then we do this 3 times for the temperature, humidity, and pressure. And then this is the table that holds all the charts. We did the same thing here for the gauge charts. And here is our video that you can see right down here. On line 302, you can see that we used an SQL query. This is how we actually grabbed our data and how we stored it. We created our own SQL database as well as buying the domain name healthyhive.co for our project. We also used another file, loaddata.php, which was how we got the data into the database in the first place. The Raspberry Pi sends it and it takes it and stores it. And that's why we created Healthy Hive.
Bushfires. One of the deadliest disasters on Earth. Men, women, firefighters, and volunteers battle for their lives in a never-ending war against this scorching hot enemy. They deploy dozens of aircraft, armored bulldozers, and trucks, aerial bombers, and they fight on foot to stop one of the most dangerous killers in the world. The work is hot and hazardous. Every move is meticulously calculated, but the fight can go pear-shaped at any second. The battle is relentless. A small spark, caused by anything, from lightning to arson, can turn into a raging inferno in a matter of minutes. Left unchecked, it destroys everything in its way, leaving tragedy and destruction in its wake. Nowhere is safe. Nothing can stop it. It just keeps getting worse. Causing nearly 100 deaths a year, bushfires also destroy the environment. They release as much carbon as Australia's annual greenhouse emissions. and annihilate the habitat of millions of animals. My project will be able to fix this problem. Hi, my name is Caleb Tang. I'm 13 years old and I'm in Year 8 at Prince Alfred College in Adelaide, and this is my project fire truck. Firefighting is a really big problem that affects millions of people all over the world all year round. My project is a fully automated, wirelessly controlled fire truck that seeks to reduce the impact of bushfires. Bushfires don't only hit hard financially, but they are also extremely harmful to the environment and are really dangerous for the firefighters. However, my fire truck is driven using Bluetooth and Wi-Fi, meaning that it can be controlled from a safe distance away from the fire. This reduces the risk of firemen getting hurt and means that they don't need to waste time putting on the correct gear, leading to a quicker departure. One of the key aims I had in mind when building my fire truck was to make it as energy efficient as possible. Traditional fire trucks are generally filled with diesel. This could potentially cause problems as diesel is a highly flammable liquid and the truck is driving into a highly flammable area. By powering my fire truck with solar panels and thermoelectric pads, it means that the truck's carbon emissions are substantially decreased. Although around the fires it would be quite smoky, in the middle of summer, the solar energy produced would be abundant for the fire truck to drive and operate without having to refuel. Furthermore, the thermoelectric pads would be able to combine the cold running water from the hoses with the blazing hot fire zone to generate electricity to power the relatively low energy consuming computers, sensors, and microchips. These two sources of energy would be ample right next to a fire, meaning that the driver would rarely have to return to refuel or recharge, maximizing the work time and efficiency of my fire truck. My project also utilizes multiple sensors and cameras to alert and notify the driver of what is going on around it, tracking the conditions of the fire and providing easily accessible, useful information. For example, fire truck will have a weight sensor, which is a potentiometer here that displays how much water there is in the tank, as well as LEDs to indicate the water level if the truck is shaking around. Fire truck also has a tilt sensor that will alert the driver if the truck is tipping over, as this can't easily be detected through cameras, and it has heat sensors to measure the temperature of the fire zone in case it gets too hot and any of the components are at risk of overheating. In addition to this, I have trained an artificial intelligence through machine learning and the TensorFlow object detection API to recognize if there are possibly any animals nearby that the firemen should save, or if there's fire or smoke that they may have missed. So, in terms of my hardware, I used an Arduino Leonardo in conjunction with the AI to create a clear and informative web page. This board also alerts the driver when animals of fire have been detected. I also used an Arduino Uno as well as a robot car base with motors, a breadboard, an L298D motor driver, a HM10 Bluetooth module, and an infrared sensor on the actual driving fire truck. The L298D motor driver allows the Arduino to talk to the DC motors, and the HM10 Bluetooth module is one of the only Arduino compatible Bluetooth modules that connects to both iOS and Android. To track and monitor the conditions of the fire, I utilized the stem cell board, an ESP8266 Wi-Fi module, a weight sensor, a temperature sensor, and numerous light sensors and LEDs to accurately and precisely record data. On the software side of things, during the creation of my project, I also employed several different coding languages and applications. I used the Arduino IDE to tell my fire truck what to do when it receives different Bluetooth signals and what to transmit in return. I also used the Arduino IDE along with the USB web library for the AI to connect the Leonardo board to the web page. When training the AI, I created a Google Colab notebook to use the TensorFlow object detection API and Python to make my model recognize the different images in the dataset that I created. Google Colab is one of the only free online GPUs in the world, and it allowed me to train my model quickly and with ease. I also created a p5.js sketch to make a web page that displays when the AI detects something. It captures a picture of what it sees before classifying it. To display the statistics of the conditions of the fire, I used RunLink. RunLink is a web-based coding system that is developed locally in Adelaide and pairs to an ESP8266 Wi-Fi chip. I used running to display the information received from the sensors on a user-friendly interface, allowing the data to be easily accessible from anywhere in the world. There were multiple problems that I faced in building my project, but I think that the hardest part was getting the object detection to work. First, I had to create a data set, which meant individually taking a few hundred photos of everything that I wanted to classify and labeling them. Then I had to train my model. Originally, I had planned to train it on the Google Coral Edge TPU, which I was getting shipped from America, but unfortunately my order got cancelled because of the coronavirus. This meant that I had to work around it. Training my model on the CPU on my computer would have been too slow, and I didn't have a GPU, so Google Colab's free online GPU was the next best thing. Training was quite a tedious process, taking over 6 hours on my slow internet, but in the end, the AI was quite accurate, and it was worth it. The inspiration for my project came late last year when I realised just how devastating bushfires could be. Although they fortunately didn't directly affect me, I had lots of family and friends who lived right next door to the fires. In the future, I have big hopes for my project. Next year when I compete again in the Young ICT Explorers, I want to make my fire truck air-based. This way, it means that it wouldn't have to drive through the bush or struggle through traffic. Rather, it would be able to simply take off quickly and attack the fires from above.
My name is Inez, and I like to compose music on my piano. I use programs such as Sibelius and MuseScore to transcribe my compositions. It's quite a simple operation for these programs because when a key is pressed, its note value is sent across the MIDI cord to the computer, which plots the note on the screen. This way, the software does not need to identify the pitch of the note being played, as it is already told so by the keyboard. But I also like to compose music on my cello, and generating a digital music score isn't as easy as it is with the piano, as well, firstly, there's nowhere to plug the MIDI cable in, and secondly, the cello does not know which note is being played. That's why I invented PyScore. PyScore is a software application written in Python that transcribes the notes played by the cello, generating a digital music score. It allows the cellist to create a music score just by playing their own instrument. So where programs like Sibelius and MuseScore transcribe the digital piano by registering what key is being pressed, PyScore instead works like the human ear. PyScore listens to the notes being played by the cello and analyzes them to calculate their pitch, which is their frequency, and then plots this on the score. So how does it work? Well, firstly, a note is played on the cello, which is captured by the computer's microphone. Then this note is analysed and its frequency is calculated. For this, I use the FFT or fast Fourier transform algorithm, as it seems to be an effective way of finding the frequency of a sound wave. Now, this is where it becomes a bit tricky because any note played on any instrument is never a pure sound wave. It's usually lots of different sound waves of different frequencies added together. So the trick was to get PyScore to choose the right frequency amongst all the other frequencies present from all the different other sound waves. For this, I wrote my own note detection algorithm, which would analyse the notes being played, sort through, and estimate the intended frequency. I did this by recording lots of notes played on my cello and looking for patterns in the test signals. I found that most of the other frequencies present were often multiples of the intended frequency, or harmonics of the note. So my program found the strongest sound wave frequency, and any others within 10 dB of this, and then took the one with the smallest frequency as the intended note. I then used the Python module iPad widgets to control the graphical user interface of the program, and the Python module Music21 to plot the notes on the screen. So now I'll give you a demonstration. I'm just going to share my screen. Share screen. Oh, hang on. It says host disabled participant screen sharing.
You should have it now.
Okay, thank you. It should be. Okay, hang on. Okay, can you see this here? Okay, cool. So I'll just run the program. So this is in my Jupyter notebook. And basically it's just loading. Yeah, I enter a note. So let's say I enter 4 crutches, starting from A in an ascending scale. So I press crutchet button and it asks me to enter a note. And as it just takes a while to load sometimes. And as you can see, they're in the correct order at the correct pitch. So now I'll do another one with quavers. Let's say I play D, F sharp, A, and D in quavers. And hopefully you should see that coming in. Yep, just note that G flat is the same as F sharp. Okay, so as you can see, there are many other features here. Up the top here, change key signature, time signature, etc. Specify the note duration, and you can also play back the thing that you've just put in. So yeah, so there are so many other applications of high school beyond the cello, as you can see. So many other instruments would benefit from applications like high school, and of course, it has I have to take it further. So many next steps like transferring it out of a Jupyter notebook and into a standalone app and getting it working in real time. So would you like to suggest a note or a couple for me to play and see if it works?
Thank you, Inez. Let's go for a G.
A G, cool. I'll just do a minimum. I'll do a minimum of G. Okay, so it's just like processing and then, yep, it should come in. Oh, actually that was meant to show a minimum of G, hang on. Can I just try one more time?
Okay.
Thank you, sorry. There's the minimum of G just there.